I'm Darrell Wallace, Manufacturing Technical Fellow at BlueForge Alliance, and I'm joined today by Brandon Lamoncha, Director of Additive Manufacturing for Humtown Products. And we're going to be talking today about the use of 3D printing technologies to support the casting industry. So tell us a little about Humtown. What do you guys do?
Yeah, absolutely. Humtown Products, we're a 3D printing company now that started, third generation family owned business. So we started out as a pattern shop, making tooling for the metal casting industry. Then we started making sand cores and molds for the metal casting industry. And we've naturally evolved into using 3D printing to be a provider. And now we're one of the largest providers of 3D printed sand molds and cores in the United States.
Okay, so how are those molds made?
So yeah, primarily we're using the binder jetting technology. So we use X1 S-Max printers. We basically take sand and we coat it with one part of the activator, and then we have an inkjet print head that comes along and then places the binder, deposits that right where it needs to be based on the raster file or the file that's loaded into it. And then the molds are harvested. We ship those to foundries all over North America, and they're pouring castings.
Okay, are the molds that you make strictly analogous to traditional sand molds, or are there some differences, advantages, disadvantages? Where does that make sense?
Yeah, so I mean, we can do a one-for-one replacement with a traditional mold, but it doesn't usually make sense. The only time we would do that would be like, let's say tooling was lost, or they couldn't find the tooling and they needed something very quickly. We could replace it. But what we're going after is some complex geometries, and what we're really targeting is the combination of multiple core assemblies or very complicated mold designs that weren't able to be cast before, and we're trying to pull those designs in using 3D printing. So that's kind of what we're targeting, and not having to produce tooling is a really big cost driver. It's really driving costs down for our customers.
Excellent. You were saying that you're trying to improve on the designs, that you take advantage of what you can do with the printed molds. Here we are at Rapid, we're looking at a lot of folks who are doing direct printing of metals. Can you talk a little bit about the comparison of, say, a printed mold for casting and what you're able to do, as opposed to how that might compare for an application for direct printing of metal?
Right. Yeah, we have a lot of customers that come to us and they said, we wanted to go and use direct metal printing, and as you're here at Rapid, you see that there are some really great opportunities to do that. A lot of times when they can't get a direct metal printed part, they come to us, and a lot of times it's alloy specific. They have a drawing and it calls out a certain alloy, and they've gone to every single person here and they cannot get that alloy printed. And we say, hey, we'll print you a mold. We'll take it to a foundry that's pouring that specific alloy, and it doesn't matter if it's 1 ounce or 10,000 pounds, we're able to print that mold, have that alloy, that exact alloy cast, and that way they don't have to go through a lot of qualifications and getting standards and everything developed. So that's really the big driver of when people come to get a cast alloy using 3D printed molds and cores.
So it's a good direct replacement for existing standards.
Exactly.
So this isn't new. I mean, additive's still fairly new, but yet you've been doing this for a while. When did you get your first printer?
Yeah, the first printer, actually we started working with America Makes before we even had our own first printer back in like 2014, and then we have our first printer was arrived in 2016. So we've been doing this for a long time, and before that, I think Ford Motor Company had brought this technology into the US 10 years prior. For the development of casting. So, like you said, not a new technology, but it took a little while for the industry to adopt it. But now I'd say we're in full scale production, and the adoption is there.
And the technology you're using is more or less the same as what you first started with, right? It hasn't significantly changed. What do you see on the horizon in terms of technology development? Is there some evolution? Where's it going?
Yeah, it's been slow. I think the adoption, not selling a lot of these machines up front really hindered that, because it's a huge investment in the machines that they made to get to this point. So what we're seeing now, larger machines, some of the companies in Germany that make these machines, I think we're going to have one here in the U.S. In a year or so that might be like a 4 or 5 times larger build volume, so we can get bigger castings. I think some of that was in the wind generation market. I think we're also seeing speed increased. Different directional passes, to be able to lay down more material, print faster, because we need to get the efficiency of these machines faster so that they can compete more with the conventional core blowing machines.
When someone comes to you for a mold, when does it just not make sense? I mean, I can't assume that it works all the time. So where would there be conditions where you just say that's not the right answer?
Some people say, oh, I could see foundries going. Foundries will always remain relevant, and a lot of those cases would be like Brembo brake rotors. It's a great casting. They're on even electric vehicles. Brake rotors aren't going away. We still need, and a simple casting like that, they've really refined the process. So high volume, I just don't ever see 3D printing really replacing simple geometry, high volume castings. It's not for it. But low volume, low quantity, it's a slam dunk every time, just from the cost savings of the tooling.
Perfect. And so obviously people can reach out to you if they want to get some molds made, but are there other resources? Where can people go to help them understand what's possible in printed molds and how additive can support casting? What sort of resources can they find?
One of the best would be the American Foundry Society. So if they're looking for castings and looking for technologies, there's actually a committee that helps develop training and education. And the other big thing is now there is a real supply base for metal casters. At the beginning, there was so few people in the space. People were afraid to jump in, get using this technology, and then what would happen if that one supplier was no longer there? Now there's a robust supply chain. There's multiple printers in North America that they would be able to go to and get their needs fulfilled, whether it's Humtown or some of the other pattern shops that have that technology. There's a robust supply chain, but I would recommend going to like the American Foundry Society, joining the committee, learning more about it, and from there you'll get to meet all of the other friendly competitors in the space that would be there to fulfill the needs.
So I think you're aware, we at BlueForge are very interested in supporting the Navy and shipbuilding and the broader defense industrial base. I know you've done some work supporting the DIB and the SIB. Can you talk a little bit about how what you're doing fits into the current needs within submarine production, shipbuilding, the broader defense industry?
Yeah, I think we've worked with foundries that are directly supporting the Navy, and I think some of the things that we can look at are on some of these larger castings that they need. We're able to make a modular mold, so size for us really is not an issue. So we've made molds that poured 6,000 pound castings for Caterpillar. And I think what we would be able to do is on some of these larger castings, now that we have 13 of these machines in-house, there's other manufacturers and other producers, we could come together collectively and print these molds, and we'd be able to support large castings in a very short time frame because we don't have to have tooling anymore. So once it's designed in CAD, we can break that up into sections, print that mold, and achieve a casting in days or weeks, not months or years. So I think that's really the biggest thing that I see as an opportunity for using this technology to support the defense.
Any parting comments? I'd love to know what's next for you in Humtown. Anything exciting on the horizon here?
Yeah, we're growing. We just installed our 13th machine. We're looking at doing our next will probably branch out into other parts of the the U.S. because shipping product from Ohio to California or from Ohio down to Texas, it takes several days, and sand is heavy and it's expensive to transport. So I could see us in the next few years, branching out, having multiple locations, but staying close to the foundries and supporting them is really our mission, and helping any way we can in the defense community. We're ready and able.
Great. Really appreciate your time today. Thank you, Brandon.
Absolutely. Good to be here.
See you.